Hello everyone. In today's session, we are going to learn how to use flow control statements in Helm with example. In this article, we are going to cover use of flow control statements in Helm with example, flow control structure of Helm, if, with, and range in Helm templates. We will focus on its templating system using simple if, with, and range statements to make Kubernetes setup flexible. These constructs allow for dynamic and conditional customization of Kubernetes resources. So this is our table of contents. First is prerequisites. You should have AWS account with Ubuntu EC2 instance, and also you should have Minikube and kubectl with Helm installed on your EC2 instance. First is use of if statement in Helm with example. The if statement in Helm's templating language allows for conditional logic. It evaluates a condition and includes or excludes specific sections of YAML based on the result. The condition is typically expressed using comparison or equality operators. It checks a condition and executes a block of code if the condition is true. The if statement can be chained with else if and else for handling multiple conditions. Common comparison operator include EQ, NE, LT, LE, GT, and GE. EQ means equal. It checks if two values are equal or not. Then NE means not equal. It checks if two values are not equal. LT means less than. It checks if the value, the left operand is less than the right operand. LE is less than or equal to. It checks if the left operand is less than or equal to the right operand. GT is greater than. It checks if the left operand is greater than the right operand. And G means greater than or equal to. It checks if the left operand is greater than or equal to the right operand. This is the simple syntax for if condition. Here under the curly brackets, then hyphen, if condition is written, then after the condition, the code which is to be executed is written here, and it is executed if the condition is true. Then there you can use another condition in it. For that, you use else if. The code to be executed if the above condition is false is written here. Then there is else condition, and the code is executed if none of the conditions are true is written here. Then you end the block with end statement. The hyphen under the curly brackets are used for trimming white spaces. If is followed by the condition to be evaluated, and else if and else are optional, providing additional branches for different conditions. Now, when the condition is said to be false, let's see. A condition is evaluated as false if the value is, if your Boolean expression says the value is false, your numeric value is 0, then it is false. If you have empty string or nil, empty or null, then it is false. Also, an empty collection of map, slice, tuple, dictionary, or array, then it will be considered as false. Now let's see the example. First, we will create a chart named Hello World. Our hello world chart is created. Then open the directory in which values.yaml file is present. Command is cd hello world. The cd command and your directory name is used to open a typical directory. Now, hello world directory is open. Now let's modify values file. Use the nano values.yaml command to edit the values file. Nano is your text editor which will open the values.yaml file and you can edit it. So you need to modify the replica count to 3 and also add the environment variables part in it. So let's add it. First, let's change the replica count to 3, or you can give any count you want. The environment variables are added. Here it said enabled is false and it has value 1 first value and value 2 as second value return. You can change it to true to enable the environment variables. Now save it using Control plus X, Shift plus Y, hit enter. Then we will modify the deployment.yaml file. First open the directory in which the file present, which is templates directory. Let's open it. Then use the following command to modify the deployment.yaml file. Now let's modify the part. We are going to add this part in the container section of the deployment.yaml file. Just right below the ports part. Here you can see the if condition is added. Under the curly brackets hyphen if dot values dot environment variables dot enable. It says that it accessing the environment variables from the values file and checking if it is enabled or not. If the it enabled is said to be true, then this environment section or block of code will be executed, or the if it is false, then this else condition will be executed and the default value will be returned. So let's save it using Control plus X, Shift plus Y, enter. In this example, the values dot environment variables dot enable checks if environment variables is enabled in the Helm values file, and if it's set to true, it includes the environment section with the specified environment variables, and if it's set to false or not defined, it includes a default environment variable with a default value. Now exit the directory using following command, which is cd. Then run the temp and command to see if modifications are done or not. For this, use Helm template and your chart name. Our is hello world. So let's run it and it executes. So this is the basic example of if statement. Since the environment variable is set to enable false, so instead of first value and second value, default value is printed. So this is our deployment.yaml file. Here you can see the default value is printed. Now let's change the enabled false to true. Follow the same procedure to modify the value.yaml file and set the environment variables to enable true. First open the directory hello world using cd command. In hello world directory, our chart is located. Use nano values.ml. Open the values file and change the enabled false to true. Save it using Ctrl plus X, Shift plus Y, hit enter. Now again exit all the directories using cd command and again run the head template command. Here you can see the environment variable printed the name and value of the first environment variable and second environment variable respectively. Is shown in the image below too. Here you can see. So this is the example of a statement. It helps simplifying things without making it too complicated. The next is use of with statement in Helm with example. The with statement simplifies referencing nested structures in Helm templates. It sets a context of block of code, reducing redundancy and improving code readability. This is particularly handy when dealing with complex configurations and nested values within the Helm chart. The with statement sets the context for the block, allowing direct access to the field within dot values, useful when dealing with nested structures to avoid repetitive references. The dot is special identifier in Helm that represents the current context or scope when used with. It allows you to reference values from current context within the new scope. So this is the basic syntax of with. The with context starts a conditional block where code inside the block executed only if the context is non-empty or executed or evaluated to be true, and end signals the end of the with block. The hyphen sign is whitespace trimming, indicates that any trailing whitespace should be removed. With is followed by the context or variable setting the scope for the enclosed block of code. Now let's see the example for it. In example, it says follow the same procedure mentioned above till modifying the values.yaml file. So First, let's create a Helm chart. Helm create hello world. Then open the directory where our chart is located. Use cd hello world. Edit the values file. Use nano values.yaml command. Now we will add the environment variables part in it. So just copy it. Add the environment variables part between the service and ingress, or you can add it anywhere you want. Make sure the indentation and syntax is correct. Pause YAML is sensitive. Then open the templates directory and modify the deployments.yaml file. First save the modification using Ctrl X plus Shift plus Y. Hit enter. Use cd templates command to open the templates directory. Use nano deployment.yaml command to open the deployment file. Then we will use with that container block after code part. So let's copy it. So we added the environment section. Here is our with statement. It has dot values, dot environment variables. As I said earlier, the dot is special identifier. It represents the current context or scope. Here, our values is our current context. It allows to refer the values from current context within the new scope. So there is no need to write values in the name or values part. This dot simply pulls the value from the values file. It refers the values environment variables as the current scope or context. Let's save the modification. Use Ctrl plus X, Shift plus Y, hit enter. Then exit the directories and run the helm template command. And our code is executed. Here you can see the environment variables are added. It shows the name, values for each of them. To align your Helm values file with the modified deployment.yaml using the with statement, you need to structure your values file accordingly. In summary, the with statement is useful in Helm templates as it provides way to manage context and improve the clarity of your template logic. It makes the template more readable and easy to understand. So it is really helpful. Next is use of range statement with example. The range statement enables iteration over lists or maps in Helm templates. It's a powerful tool for dynamically generating Kubernetes resources based on a list of values. This feature is crucial for creating scalable charts that can adapt to varying numbers of components or services. The range statement iterates over the list or map provided. It is valuable when generating resources dynamically based on input values. This is the basic syntax for the range statement. The range iterable starts the range block, where iterables is the data structure over which you want to iterate. The block of code will be executed for each item in the iterable. And lastly, the end statement that signals the end of the range block. The hyphen under the curly brackets is used to trim the white spaces. Range is followed by the iterable. For example, a list or map. The block of code inside the range is executed for each item in the iterable. Now let's see the example. Follow the same steps as each statement until modifying values.yaml file. So let's first create a Helm chart using Helm create command. Our chart is hello world. Now the chart is created. Open its directory where the chart is present using cd command. Open the values file using nano values.yaml command. Now let's add the environment variable section in it. Add it after the annotation and before the pod annotation. The environment variables are added with name and value, three of each pair. Save it using Ctrl plus X, Shift plus Y, hit enter. Now open the templates directory using cd templates command and then modify the deployment.yaml file using nano deployment.yaml command. So let's open the directory cd templates. Now open the deployment file using nano command. Then add the environment variable section in container section as shown below. So add it after the image pull policy in containers section. So let's add it. Here, the environment is defining the environment variables, then range dot values dot environment variables. This iterates the loop. It initiates the loop that iterate over the items which are nothing but name and values. Dot values dot environment variables assumes that it is an array of the list of objects, and for each list it will execute the code within the loop. So the modification using control plus x plus y, hit enter. Now exit the directories using cd command. Then again run the helm template command. What it say? Um, Sorry, uh, your h should be small. Sorry for that. Now again run the helm template command, and you can see in the deployments file our environment variables are visible, and it correctly iterated 3 times. The name and the values are written here. See the output in the below image also. The range statement is used to iterate over the list of environment variables defined in dot values dot environment variables. For each variable in the list, a new block is created in the spec.template.spec.containers.environment section of the deployment. The template within the range block access properties of each environment variable such as name and value. Now let's see the importance of flow control statements in Helm. The importance of flow controls, if, with, and range in Helm cannot be overstated. Here are the key reasons why they are crucial in Helm. First is dynamic configurations. The if statements enable conditional adjustments, allowing dynamic configuration based on different environments. This is crucial for handling variations in configurations across environments such as development, testing, and production, or based on user input. Second is reduced redundancy with. The with statement simplifies referencing nested structures, reducing redundancy and enhancing code readability. This is beneficial for improving code readability and maintenance, especially when dealing with complex data structures such as nested maps or objects. Third is iterative resource generation with range. The range statements facilitate the dynamic creation of resources essential for scalable and adaptable Helm charts. This is particularly useful when dealing with scenarios where you need to generate multiple resources dynamically, such as deploying multiple instances of a component or configuring resources based on dynamic input. Then last is adaptability and readability. Helm flow controls enhance adaptability by adjusting configurations, promoting modularity, and making charts more readable in diverse deployment scenarios. The improved readability is a key benefit as flow control statements help express complex logic in a more structured and understandable manner, making Helm charts more readable in diverse deployment scenarios. So the use of flow control statements in Helm charts provides flexibility, reduces redundancy, supports dynamic resource generation, and it enhances the overall adaptability and readability of Helm charts in different deployment scenarios. Next is best practices of flow control statements in Helm. Here are the main best practices for using flow controls in Helm charts. First is whitespace trimming. Use of hyphen to trim unnecessary white spaces, ensuring cleaner YAML output. This trims the unnecessary white spaces at the beginning or end of the lines, preventing unintended line breaks in the generated YAML. This results in cleaner and more readable output. Second is consistent indentation. It maintains consistent indentation for a well-organized and readable code structure. It enhances the readability. It's important to maintain the uniform indentation style throughout the templates to make the code structure clear and easy to follow. Third is commenting. Add comments to explain the purpose of flow controls and any complex logic for better understanding. They explain the purpose of flow controls, provide context of complex logic, and aid in understanding the template's functionality. Next is use helper functions for complex logic. Consider moving intricate or reusable logic to helper functions in helpers.tpl to keep main templates focused. Helper functions defined in helpers.tpl help keep main templates focused and organized. They are especially useful for encapsulating complex logic or calculations, promoting reusability across different templates. Next is avoid nested flow controls when possible. While Helm supports nested flow controls, excessive nesting can lead to complex and hard to read templates. So limit the depth of nested flow controls to maintain simplicity and ease of management. Now next is error handling. Use -fail message in if statements for explicit error handling to avoid silent failures. It allows you to raise an error if a specific condition is not met. The next is group related logic. Group related logic together to improve clarity and separate different concepts into distinct sections. Grouping related logic together improves code organization and makes it easier to understand the purpose of each section. Next is avoid hard coding values. Refrain from hard coding values directly within templates. Rely on values from values.yaml or external configurations. Then next is testing and validation. Implement thorough testing of Helm charts, including scenarios involving different flow controls paths. Hard coding. This helps ensure that the charts behaves as expected and are resilient to different configurations inputs. The last is documentation. Maintain documentation outlining the purpose and uses of flow controls within Helm charts. These practices collectively contribute to creating maintainable, readable, and error-resistant Helm charts with effective use of flow controls. They help chart maintainers and users navigate and understand the code base, leading to a more positive development and deployment experience. So, in conclusion, Use of flow control statements in Helm with flow controls like if, with, and range involves keeping things tidy, using helper functions smartly, and simplifying without making it too complicated. It's about organizing, testing, and documenting for practical use in different situations. It ensures that your Helm charts are well structured, adaptable, and straightforward for seamless use in diverse environments. Thank you.